generally, like when you're talking about the like discrete random variables or probability distributions, like if you look at the probability distribution, if you have to look at distribution, you got one is the discrete random variable, discrete and continuous. So why do we firstly call them as discrete and continuous? Now see, discrete values are basically like, for example, you're rolling a dice. Okay, there are two words that we need to clarify them. First thing is that why distribution? Why do we call it as a distribution? And secondly, why discrete and why continuous? What's the difference between them? So when you're talking about discrete as a variable, now discrete simply means that firstly distribution. Let's talk about. So whenever you're doing an experiment, there'll be multiple outcomes. Now, for a particular outcome to occur, there'll be certain probability. So probability gets distributed amongst each outcome. Let's say you're rolling a dice. Now, when you're rolling a dice, the probability of like rolling a dice and getting the scores will be distributed. Let's say 1, 2, 3, 4, 5, 6. This will be 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, and 1, 6. So each of them are getting their probability share, like you can say chances. So this is basically when you're defining a random variable. This is the random variable. The random variable is what can occur. What are you observing? And Px is its corresponding probability. Now for the word discrete. Now discrete is like obviously the individual outcomes. Like they are not a range of values. They're individual, like generally the whole numbers that we talk about. Like for example, here like you've got 1, 2, 3, 4, 5, 6. These are like your discrete values. But continuous, for example, if you're measuring height of people in a country, like let's say there are 500 million people in a country. Now you will have so many outcomes that you can't classify people's probability being in certain exact value, right? So then you use a range of values, and that's where it comes as continuous. So in continuous, even if a decimal point is included, like what's the probability that a person's height is between 100 to 200? Now 100 to 200, all the possibilities, all the answers will be taken. So that's why we use continuous. Now out here, when you're talking about discrete or continuous, always remember the net probability is going to add up to 1. So now here, if you look at in continuous, what we're studying is basically called as normal distribution. And here we'll be studying discrete random variable, we'll be studying this and binomial distribution. So discrete random variable, you have two things to study, like general table type questions, and then you have one is explicitly binomial distribution questions. Now conceptually, I'm going to take like the next 20-25 minutes. I'm going to cover the concepts of all of them, and then we're going to do certain set questions for practice. So let's just begin. The first part. Now, for example, let's say, what are the key terms related to discrete random variable? Now, when I'm doing discrete random variable, now first thing is that like, okay, let's say you are doing an experiment where the values of x that is expected is, let's say, 1, 2, and 3. And its corresponding probability is, let's say, 1/3. This is 1/3 and this is 1/3. So the first thing that we need to understand is the net probability. Sometimes they'll give you one of the missing values. So like one value is missing. So they're going to just give you like, okay, this is the missing value is A, and find out the value of A. So finding out the value of A is basically you're going to add up all the probabilities and equate to 1. So as simple as that. So let's say here if I got 1/3 plus 1/3 plus A, this should be equated to 1. So that's your experimental evaluation, like the net probability for a fair game is going to be adding up to 1. So A is going to be 1 minus 2/3, which is also 1. So that's obvious. plus 1/3. So for any discrete or continuous variable, remember the probability. Sum of the probability, you can see, sum of the probability Pi is going to be 1. So if there are infinite outcomes, probability still is going to add up to 2. Now, what are the few other interesting facts? Like, one discrete random variable is measured in terms of something called as expectation or expected value. Okay. Now, expected value. So, what exactly is expected value? So, when you talk about expected value is nothing but sigma xi pi. So, expected in standard level syllabus, we have only basic things. They're like HLMA, you have got the variance and all this stuff, which is you don't need to worry about. Expected values sigma xi pi. Okay. Now, how do I calculate sigma xi pi? Is basically multiply the x values with corresponding probability. So if I multiply, let's say 1 with 1/3 plus 2 with 1/3 plus 3 with 1/3. So this net probability out here is going to basically add up to, this is, if you add it up, that's going to be your expected value, or you can say average score that you can expect. So let's say this value comes out to be whatever it is. This value will be 6 times 1/3, which is 2. So on an average, you'll expect a score of 2 with such probability distribution. Our next question is, what about if we have got, let's say, a question like this? So let's say there's a question which is where we have got the random outcomes as 1, 2, 3, 4, and I've given that the probability of getting 1 is 0.1, probability of 2 is 0.1, probability of 3 is A, probability of 4 is B, and I have given expected value is 2.5. And how do I calculate this? Basically, the missing values of A and B. So if you just think about, the first is very simple, like, you have to add up all the probability and equate to 1. So it'll be like 0.1 plus 0.1 plus A plus B is going to be equals to 1. So you can say A plus B is going to be equals to 0.8. That's your first equation. That's first simultaneous equation. The next half that I've given is basically the expected value. So we're going to use this expected value. So since the expected value is 2.5, I'm going to add up the two equations. So 1 times 0.1 plus 2 times 0.1 plus 3 times A plus 4 times B equals to 2.5. So this is going to be 0.3 plus 3A plus 4B equals to 2.5. So 3A plus 4B equals to 2.2. And so you got two equations. So 3A plus 4B equals to 2.2. And now we're going to solve these two equations to get the desired answer. So when you solve this, we are going to get the value as the value of, let's say, A is 1 and value of B is negative 0.2. So since these values are like practically not possible, you can say such experiment is not possible. Generally in exams, you'll be given certain questions where you have like, you're getting the proper values of A and B. So this is like the general type of question that has been assessed so far. I want to take one more question, which is basically on like this kind of question, which is referred as a fair game problem. Okay. Now, generally, what's the logic of fair game? So, like when you talk about fair game is basically when you got expected value is 0, as simple as that. So if you play a particular game or a quiz where there's certain winning prize and there's certain prize that you pay to play that game. Ideally, you should not have, by end of the game, whatever money you have given to play the game should be back with you. That's a fair game. You can simply say that neither you should win or lose. So your winning expected value should be 0 for a fair game to be fair. So now let us say if you got a value which is x and corresponding value bx. Suppose the x values are like 1, 2, 3, 4, 5, and 6. So if you roll a dice, assume that if you get a 6, you get $10. If you get 5, you get $2. If you get 4, you get $1. If you get 3, you get $0. If you get 2, you have to pay $1. And if you get 1, you have to pay, let's say, $5. And since this is the fair dice, so the probabilities are all going to be 1/6, 1/6, 1/6, 1/6, 1/6. Every problem, all these things, the numerics or digits that I have given can be different. So here, for example, I have taken $5 negative $5 if you get a score of 1, negative $1 if you get a score of 2. So this is what you negative and positive means. Positive is you're gaining, negative is you're giving. So what conclusion can be drawn? Now, number one is this game a fair game? Is this game a particularly fair game? So in order to see a fair game, your expected winning should be 0. So I'm going to find out expected winning and loss that I'm having. So expected winning firstly is going to be negative 5 times 1/6 plus negative 1 times 1/6 plus 0 times 1/6 plus 1 times 1/6 plus 2 times 1/6 and plus 10 times 1/6. So if you simplify this, now see, I'm going to win this money only if I get 1. So you don't need to worry about X out here because you're talking about the expected value for profit that you're getting. So my major part is going to be the profit function. So here when I'm looking at this expected value of X is the negative 5, negative 1 plus 0 plus 1. Since denominator is all the same, I'm just going to add up all of them upon 6. And you notice that this is 12 plus 1, 13. 13 minus 6 is basically 7/6. So since I'm getting $7/6 as a return, it is not a fair game because then I'm earning a profit of $7/6. So this is the meaning of a particularly a fair game. So more or less, these are the kind of questions that are generally covered in your exams. They are mostly covered for at least the discrete random variable. So here what we have is basically the random variable has got 3 unknowns, P, Q, R. So that's probability for 0 is unknown, probability for 1 is unknown, and probability for 5 is unknown. But it has been given that probability for X greater than 2. Now greater than 2 means probability of 3, 4, and 5 adds up to 0.6. So you just add up 0.2 plus 0.1 plus R equals to 0.6. So that's going to give you straight away R is 0.3. So the net probability when you look at here, so the net probability, these 3 should add up to 0.6. That gives us straight away the R value as 0.3. Now since expected value is 2.9, find out the value of P and Q. So you add up all the probabilities and equate to 1. So you can just simply, because since I know this is 0.6, this should be adding up to 0.4. So P plus Q plus 0.1 plus these are 0.6 equals to 1. So you get P plus Q equals to 0.3. So that's your first equation, and then we have been given the expected value is 2.9. So if you get if you solve for this, like expected value, so expected value will be 0 times p, 1 times q, 2 times 0.1, 3 times 0.2, 4 times 0.1, 5 times 0.3. They all should add up to basically 2.9. So out of that, we already know since 0 times p will become 0 itself. So if we can check the correct exact answer, what we're going to get is basically here. Let's check out the exact value of the answer, which is so you can see that 2.9 equated to this. So that gives us 2.9 plus q plus 2.7 equate to 2.9. So q is basically 0.2. And since you already know p plus q is 0.3, we just add up to add those and equate to 0.3. So q is 0.2, so p is 0.1. So that's the exact value. So in this question, what we have is basically there are three regions, A, B, and C. The probability of hitting region A is 1 upon 24. Probability of hitting in region B is 4 upon 24. Probability of hitting in region C is 7 upon 24. So these are the given probabilities. So if you hit within region A, you get $10, 10 points. If you hit in region B, you get 6 points. If you hit in region C, you get K points. And if you hit outside, you get negative 4 points. So first thing is that, see, this is the probability of hitting in the region ABC. So what's the probability of hitting outside? So you're going to add up all and subtract from 1. So if you do 1 upon 24 plus 4 upon 24 is 5 upon 24. 5 plus 7 is 12 upon 24. So 12 upon 24 is a chance of hitting in region which is outside, which is inside the region A or B or C. So if you do 1 minus this, which is going to be 12 upon 24, which is nothing but 0.5. The probability of hitting in region outside is going to be basically 0.5. Now, since they're saying that, given that the contest is fair, find out the value of K. So given that the contest is fair, find out the value of K. So in order to find the value of K, what we're going to do basically is, we are going to do 10 times 1 upon 24 plus 6 times 4 upon 24 plus K times 7 upon 24, and probability if you hit outside is negative 4. So negative 4 times 0.5. And this should add up to equal to 0. Because probability of hitting in region A is 1/4, 1 upon 24, hitting region B is 4 upon 24, hitting region C is 7 upon 24, and hitting outside is 0.5. So 0.5 times negative 4. And these all should add up to basically 0. Because net for a fair game, expected value must be 0. So this is the logic of the fair game, basic understanding of the discrete random variables. So if we solve for K in this particular problem, we should get the answer as, let's check out the answer exact value. So the value of K is, that makes the game fair, is basically 2. So K equals to 2. So if you take 2 here as the number of points, so in this case, if you take K as 2 here and you calculate the expected value, your answer will come to be 0. So that's what it means, for it to be expected and fair.